is the first part of the table. Now, the table is saying complete it on this slide and then on the next 2 slides. So as I stated, there are 3 slides that deal with tables, and we're going to be filling in the missing boxes in the table. Now, it is saying write the operation or operations in words, not in symbols. The operation is another way of saying operator. Now, the first line is completed for you. Now, hopefully from this example, you will be able to understand the words operator and object. Now, in A, the first row, we have a square root symbol. That square root symbol is the operation or the operator of this problem. Now, the object is the number that's underneath. Okay. Now, this is where you truly understand definitions and terms. Now, in the second row, we have a mixed number. Well, the operation or the operator is what puts the mixed number together. And if you remember, a mixed number is made up of a whole number plus a proper fraction. So the operation is based upon taking the number, whole number 4 and 2/5 and adding it together. The operator is what puts the mixed numbers parts together. Now, C, you're going to notice we have a fraction. Now, in the object, which are the numbers, the numerator is 8, the denominator is 9, but we're looking at what does this symbol between the 8 and the 9 mean? That is your operation or operator. This is division. Okay? So, the operation or operator, okay, is the mathematical operation that puts the numbers or objects together. That is the catch. What is the mathematical operation? An operation is going to be add, subtract, multiply, and divide. Now, we're going to look at some more. Now, this table, okay, you're going to be asked to give some objects. Now remember, objects are numbers. Okay, and then the operations are the symbols or what we are doing. Well, if you look at D, the object is the number inside the absolute value bar, which means our answer for the object is -10. Now, the operation we're told for E is square. Now, square is that little piece. Now, the object is what am I squaring? I'm squaring -8. Okay, I'm squaring -8. Now, be careful with F because we're talking about, again, the square, but the square is only dealing with the number 8. It has nothing to do with the negative sign. The square is saying I have a negative 8 times 8. That is my square. Now, we're getting into some more interesting ones. The operation for G is multiplication. Now, this is going to have 2 parts to it. We are multiplying 2 and then parentheses x plus y. Notice how I put the comma between. Okay, so therefore it's 2 comma x plus y. That is multiplying. That is a multiplication operation. A number next to a parentheses. Now, we got to look at what we have. We're talking about A and B. Okay? Well, A and B is just the numerator. What are we doing just in the numerator? We are adding. That's the operation. We're not looking at the 2, the denominator. No, not yet. We're only looking at A, comma, B. Okay. Now, I. Okay. Now, notice it says A plus B, comma, 2. Well, what this is saying is that I'm taking the numerator, which is up here, and I'm taking the denominator, which is here. What is happening here? What is the line between? This is going to be division. The objects, the operation. Now notice we put A plus B, comma. That is grouping the numerator together. Whereas in H, we took the numerator and we separated it. A, comma, B. What's between the A and the B is addition. That's the plus sign. Now, let's see what you can do with these. Okay. Now, this one, okay, this is telling me the objects. The objects are A plus B, which is this first fraction, and then I have B over 2, which is this fraction. What operation is putting them together? Addition. Now, 12. You need to understand that this fraction or set of fractions can also be written in this form. A plus B divided by 2. This is the same as what I just wrote. Now, why could I write A plus B with one fraction bar and just single 2? because I have a common denominator. And we're talking about division. Now, this can be written a couple of ways. You can take each fraction and say, okay, in this case, we can do them separately, which is A and 2, comma, B and 2. That's division. But we also can say A plus B, common 2. That is also division. So notice that I can say K in two different ways. I can take each fraction separately because the line between A and 2 in the first fraction means divide. And I can take B over 2, which is my second fraction, because the line between B and 2 means divide. But I can also put A plus B as one object. That's my numerator. My denominator is 2. The line in the middle means divide. So when you get a problem like K, you could have more than one answer. So watch your choices when they're asking you to put objects in, because division is happening in both fractions, which is why in the first line, that the first K, I could put A in 2, B in 2. Okay, but I can then also indicate A plus B divided by 2. Okay. Now, this is using the words operation or operator and an object. An object are going to be the parts of the operation we're using. Now, this next set of problems are going to show you about the distributive property. But they're also going to bring in some old stuff. So be careful between some of these problems. They are not going to always give you the same answer. Now, if we look at 5, it's asking us to simplify each of the following expressions. Okay. Now, think carefully about when and how. This is purposely put there, this when and how, because they're combining old stuff and new stuff. Can you tell the difference of when the distributive property needs to be used and when it doesn't? Well, if we look at A has a parenthesis with a plus. This is using the distributive property. This problem uses the distributive property because inside the parentheses I have a plus sign. Okay, so that means the 7 is multiplying by a 2, which is going to give me, in this case, 14. This 7 is multiplying by a positive h, which gives me 7h. This is my answer for A. But notice B. The distributive property is not used here because there is no plus or minus sign inside the parentheses. So the answer is found by multiplying the numbers and placing H at the end. So I'm going to take the 4 and the 6 and multiply them. This is going to give me 24 with an H at the end. No distributive property. Okay. Now, we're going to get to some bigger ones. Okay, now, this is where you have to be careful. This is inside a bracket. It's inside a bracket. Remember the rules for order of operations? We do what's inside the parentheses, if we can, and then we do what's inside the brackets. So what's happening here is this 3 is staying out in front. This is saying 5 plus H plus 5 plus H. This inside the bracket gives me 10 plus 2H. Now I distribute. This 3 multiplies by 10. This 3 multiplies by a positive 2H. This is my answer because I do order of operations. I have several grouping symbols. I have parentheses inside parentheses. Now, D is a little bit different. D has 3 next to this parentheses. Well, that means I am going to distribute the 3 times 5, the 3 times 5, and then the 3 to the H. This will give me 15 plus 3H. But don't forget, I have a third parentheses that is back to back right here. That goes back here in parentheses form. 5 plus H. The first 2 terms, remember, order of operations, I multiply from left to right. Well, that 3 is multiplying by 5 plus H in the first parentheses, which is why I got, in red, 15 plus 3H. But now, remember, we FOIL. This 15 multiplies by 5, which gives me 75. This 15 is multiplying by H to give me 15H. Now, this 3H positive is multiplying by 5 to give me 15H. 15H times H gives me plus 3H squared. Now remember, we have a power of 2 right here. We have to write this answer in descending order, which means for this polynomial, I would write 3h squared. Now remember, when you FOIL, these two terms are going to come together, which is plus 30h, and the 75 is at the end. Order of operations. One has 2 parentheses inside a bracket. I have to then combine terms of those brackets. That is giving me 10 plus 2h. Then I distribute. Okay. Now, these next 2 slides are what we call algebraic proofs. Yes, you're getting into the world of proofs. Now, to do these proofs, we are going to have to make a judgment call. We are going to have to use numbers in replace of the letters. Now, let me show you what I mean. This is saying show that a plus b divided by 2 is equal to 2 separate fractions. A divided by 2 plus b divided by 2. But, now notice this but. This but is going to talk about this part. Well, that part in yellow is on the second slide that's coming. It's part of the proof, but I have to do what's in front of the but and then do what's behind the but. But as I said, these are algebraic proofs. I am going to have to make a guess. Does it matter what I guess? No. I want to pick a number for A. I'm going to say it's 3. I'm going to pick a number for B, and I'm going to call it 4. Can I pick any number? Yes. Pick any number you choose for A and B, but you cannot have A and B be the same number. They've got to be different. Because is A the same as B? No. Well, now we're going to do the proof. We are going to write this first fraction as 3 plus 4 with a 2 on the bottom. And then I'm going to write 3 over 2 plus 4 over 2. Now, you need to ask if the left side of the equation equals the right side of the equation. Answer is yes. Because if I put the numerator together, 3 plus 4, I am going to get 7 over 2. But if I take these two fractions that have a denominator of 2, notice they're the same. So that is telling me, just like I did in the table, line K, they can be written 2 different ways. They mean the same thing, and they are going to be equal. Okay, now let's look at the second half, the part in yellow that I didn't touch. Notice that's here. Well, notice I've got to use the same value for A, which was 3, and the same value for B. Okay. You need to use the same values that you chose for A and B from the last slide. Well, now we're going to substitute them. Now, notice what you get. I have a 2. Now this is going to be 3 plus 4 in the bottom. They are saying that this does not equal 2 over 3 plus 2 over 4. Well, this side is easy to do. We know that this side is going to be 2 over 7. But this side, you need common denominators to add. And that means that this common denominator is going to be 12. This will give me 8. This will give me 6. Well, if I put this together, I am going to get 14 twelfths. Notice this does not equal 2 sevenths. So by flipping the fraction, this side can't be equal, but this side can be equal. This is an algebraic proof. You are having to choose your own numbers for A and B, and then you work with the part before the but, B-U-T. Then you work with the part after, B-U-T. And you'll notice that the part before but is true. The part after the but is also true, but it required more algebra work. Okay. Now, let's look at the next slide. From this proof, notice what we get. It is asking you to simplify. Well, if you look at each one of these problems, you are going to find that they are all fractions. Now, if there is a single number in the denominator, and I'm going to write this up here. If there is a single number in the denominator, you rewrite into 2 fractions when there, when there is a single number. Well, notice in A, there's a single number. In B, there's a single number. In C, there is a single number. But look at D. Okay, this denominator cannot be written as two fractions. Therefore, it cannot be simplified. Okay. The denominator cannot be written in two fractions. I've got a binomial in the bottom. It's not a single number. Whereas in A, notice what I have. I have 7x divided by 7 plus 7 over 7. Now I can simplify each fraction. This will give me x plus 1. From the two fractions, I simplify each fraction. Same thing with b. This is x over 7 minus 7 over 7. Well, this fraction is going to stay because I can't reduce it. But look at this fraction. What does that fraction equal? It equals 1. Now, be very careful with C. C has got a negative out in front, which means I take x over 7 minus 7 over 7. This negative sign is the one out in front. Well, notice what happens. Inside the parentheses, I'm going to have x over 7 minus 1. But remember, that negative means take the opposite, which means I have a positive right here, which is going to give me a negative x over 7. But then this negative is distributing to give me positive 1. This is my answer for C. And the key is it's only possible to simplify if I have a single number or term in the denominator. Okay? Any question with this? Okay. Now, vocabulary and another algebraic proof. This is saying, can an exponent be distributed over addition? Well, in other words, now we got to translate this phrase. This phrase is saying, is a plus b squared equivalent to a squared plus b squared? Well, that is saying that we have a plus b squared. Now, equivalent means equal. Now, it says, if not, provide a counter example and show how a plus b squared can be rewritten. Well, they're telling you what to do. What does this exponent mean? It means what's in the parentheses is appearing twice. Remember, it's appearing twice. And remember, this is FOILing, which is saying A squared, this A multiplies by this A, plus A times B plus. Now remember, A comes before B plus B squared. When you FOIL, these two terms come together, which means I have 2ab plus b squared. This does not equal a squared plus b squared. And you're going to say, well, why? Look at this term. Look at that term. Now, they're saying counterexample. Well, let's use numbers. Okay. If I say A is equal to 3 and B is equal to 4, notice what I'm going to do. 3 plus 4 squared. Does it equal 3 squared plus 4 squared? Order of operations says I've got to add the two numbers and square them. 3 plus 4 is 7. 7 squared is 49. But if you look, 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. 49 does not equal 25. This is what they're talking about for a counterexample. You pick numbers for A and B. And the answer is no. You cannot, an exponent does not distribute over addition. No. An exponent does not distribute over addition. And we just proved it. Okay? Now, my last two slides deal with what we just did here, but it also goes back to the table that we just did. It is going to ask us to write the operators and the objects. Now notice what these two say. It says evaluate each expression when n equals 5. Okay, n is equal to 5. Now it says list the operations that you applied to the value of n in the order they were applied. Okay. Now this is the fun part. Then provide a second list of operations that contains the inverse operations. Well, if you do the first sentence, you're just reversing the opposite. Well, this is saying, sentence 1, we are going to evaluate. This is 3. Now, I like to put 5 here, minus 2. This is 25 times 3 is 75 minus 2 to get 73. This is sentence number 1. We evaluated. Now, number 2. Okay, now, sentence 2. We squared 5. Then we multiplied by 3 and subtracted 2. Okay? We squared 5. We put these two together. We then multiplied by 3. Which gave me 75. And then we subtracted 2 to get 73. Now, all you have to do for sentence 3 is reverse sentence 2. We are going to add 2. Now, it said multiplied by 3, so we are going to divide by 3 and take the root, the square root of, and take the square root. Okay. Now, see what I do. I have the answer for equation 1. Now let's follow these steps. If I take my answer, and my answer is 73, okay, I'm going to add 2. That gives me 75. And then I'm going to divide by 3, which gives me 25. And then I'm taking the root. This goes backwards. I'm reversing. Okay. So this is what they're asking you to do. You take the answer in the inverse, then provide a second list that contains the inverse operations in the reverse order of the first. And notice, what does the root of 25 equal? 5. The number they gave us in sentence 1. I'm using the reverse. Okay. Now, this one gets a little harder. We're still going to use n is equal to 5 right here. Okay. Now, the first sentence says to evaluate. So from sentence number 1, I have 2 parentheses 5 minus 1 divided by 3. Now, order of operations. 5 minus 1 is 4. Okay, so this gives me 2 times 4 divided by 3. Well, 2 times 4 is 8/3. Okay. This is sentence number 1. I evaluated it using n is equal to 5. Now, number 2 begins with the second sentence. List the operations you applied to find the value of n. This is the value that we get at the end, the value of n in the order you applied them. So how did we get to 8/3? So from sentence 2, we state that we subtracted 1 from 5. Then we multiplied by 2. And then we divided by 3 to get our answer. Okay? We subtracted. 5 minus 1 gave me 4. Then we multiplied. 4 times 2. That gave me 8. And then what does this line between 8 and 3 mean? Divide. Now, right here, then is the third part. This is the third part. The third sentence. Then provide a second list. Well, if you get this one right, you've got the third sentence because you are doing the opposite. Okay? Because you're taking the answer and going back so that we prove that n is equal to 5. Well, okay. For the third sentence, now we're starting from the back. We said that we divided by 3, which is the last thing. So we're going to multiply by 3. Then we're going to divide by 2. And then we're going to add 1. We are doing the opposite. Now watch what I do. I'm going to prove to you this. Take 8/3. Okay? We are going to multiply by 3. Okay? So if I multiply 8/3 by 3 over 1, notice these 3's are canceling out. I get 8. Okay. Now I'm going to divide by 2. Well, I'm taking 8 and I'm dividing by 2. This gives me 4. And then I add 1 to the 4 to get 5. I'm learning about inverse operations. And this is the end of 2-9. Enjoy.